Okay, probability of two independent events. Basically, the one probability, chances of getting one thing has no effect on the other thing. And here, when you're looking at them both occurring at the same time, or one after the other, because one event doesn't affect the other event, it's just the first probability multiplied by the second probability. Here, Bobby has 9 dimes and 7 pennies in his pocket. He selects a coin and replaces it. When then he selects another coin. What's the probability that both coins are dimes? Well, how many dimes does he have? He has 9. Out of how many total coins? 16. So that's the probability on the first dime. Since he puts it back in his pocket, the second time he draws a coin, he still has 9 dimes to choose from and a total of 16 coins to select. So that's the probability of the second coin. So you multiply across, you get 81 on top over 256 on the bottom. However, if what you do the first time affects what you could get the second time, then you multiply, but your second probability is probably affected by your first probability. Still the same situation, but instead of putting the coin back, he keeps it out. So, probability of getting 2 dimes, well, there's still 9 dimes out of 16 possibilities. But now he's keeping that dime in his hand. Now he's drawing a second one. He only now has 8 dimes left in there to choose from. And since he still has that one coin in his hand, there's only 15 coins left in his pocket. So now we can multiply across the top, multiply across the bottom, we get 3/10. Here, 3 dice are rolled. What's the probability that one dice is a multiple of 3? One's an even number, and 1 is a 5. So it's going to be 3 things multiplied together. Probability that it's a multiple of 3. Well, a multiple of 3 would be like a 3 or a 6, and there's only 2 of those, so it's 2 out of 6. An even number, that would be a 2, a 4, or a 6. That's 3 possibilities out of 6. And probability that it's a 5. That's 5 only occurs once, so it's 1 out of 6. Because what you do on one dice has no effect what you get on the next dice. So then you multiply across the top, multiply across the bottom, we get 1 over 36. Now let's take a look at this. A game show host. We have 20 chips, 11 show that they get a computer, 8 are trips, and 1 is a truck. He draws a chip at random, does not replace it, find the probability of getting a truck. The computer, then a truck. So, probability of the computer, we have a total of 11 computers out of 20 different possibilities. Not being replaced, so we now need to get a truck. Well, how many trucks are in there? Still just 1. But since that first chip from here was not replaced, there's only 19 possibilities left. So your probability would be 1 out of 19. So we multiply across the top, multiply across the bottom. Same type of thing, but he's not replacing it. And now we want to get 2 trips. Well, there's 8 trips. So there's a trip of 8 possibilities out of the total of 20. Not being replaced for the second time around, there's only 7 trips left in there because the first trip was kept out. And since the first trip was kept out, there was only 19 possibilities left. Now we multiply across the top, multiply across the bottom.